Now what we'll do is we will divide this motion, which means motion of the ball thrown up with velocity VA into two halves. Thrown from A, covering the points A, B, and C in order from A, where B is at a height h by 3 from the ground. And the second motion, the second half of the motion, would be considered to be one such that it is dropped from C, moving downwards, covering the points C, B, and A in order, where B is at a height h by 3 from the ground. Thrown up with A, B, and C, where actually I should have written it's A, B, and C, like this. Sorry. Okay. And it is really important to understand the symmetry that we come across here. Okay. Right. So upward motion from A to B, then C. At C, the object is momentarily at rest, which means velocity at C is equal to 0, which means velocity at C is equal to 0. And then the downward motion to be considered as 1 being dropped. Why? Because at the maximum point, velocity at C is equal to 0 and it moves down and reaches A. And in both cases, it is crossing the point B, which is at a height h by 3 from the ground. Now this motion, the path is really important. It goes like this, then comes like this, right? So it is coming to this point B like this, 1 and 2. Okay. So the time taken to cover A to B, A to C is time of ascent TA. Now, for the motion along AB, now see guys, this is the calculations here are very tricky. Trust me, it took me really long time to write it in an organized way, and to make sure that the idea is as clear as possible. So the number of steps would definitely be more here. Yes, I do understand that's the case in almost every question. Uh, Apologies again. So what I would say is, please write this along with me, right? Because the intention here is not just to solve the question the quickest way, but it's also to understand every possible concept, underlying concept in the given problem, which could be a potential question in the coming JEE Mains, if that makes sense, right? So please, it's a humble request that you write these things along with me. So for the motion along AB, the displacement are SA and SB respectively. Velocity is VB, it's VA and VB respectively. The time is TA and TB. Velocity is upwards. Acceleration due to gravity is acting downwards. Displacement is from the initial position to the final position acting upwards. So what does this imply? This implies that displacement S is positive, velocity V is positive, and acceleration A is minus G, negative, acting downwards. So V is equal to U plus AT. V is the final velocity at the final point, which is at B. Therefore, is VB. U is velocity at the initial point. At A is VA plus A is, my bad, this is, plus A is minus G. T is time to reach B. How? Time to reach B while it was moving upwards. Okay. So VB is VA plus y minus A G TB. VB is VA minus GTB. Therefore, minus GTB while going upwards is VB minus VA. Yes, nothing conclusive so far. Now let's see what's the case with the same motion along AB. But this time using equation V square minus U square is 2AS. Yes, we're not using the equation S is equal to UT plus half AT square. Instead, we are using V is equal to U plus AT, and V squared minus U squared is 2AS. Multiple ways of looking at the same problem. What is V? Final velocity, VB. U, initial velocity, VA. A is again minus G. VB squared minus VA squared is 2 into minus. What is S? S is displacement, which is final position minus initial position, which is SB minus SA. And what is SB minus SA? It is this distance or this height AB, which is h by 3. So we have VB squared minus VA squared is minus 2G into h by 3. But what is h? Okay, to understand h, we need to come to the maximum height AC. So when the object is projected from A, it reaches the maximum height where it is momentarily at rest. And since it is momentarily at rest, at that point, the corresponding velocity Vc would be equal to 0. Applying V squared minus U squared is 2AS. Vc is 0, which means we have 0 squared minus U is VA minus G. And this time S is, what is S? S is, this S is actually equal to SC minus SA, which is equal to this distance, equal to this height, which is the complete height, H. So we get VA square is equal to 2GH, or H is equal to V squared by 2G. What do we do with this? We bring this H is equal to VA squared by 2G. So G over G is 1. This becomes minus 2VA squared by 3. Right? Oh, sorry, minus VA squared by 3, right? So 2 by 2 is 1, G by G is 1. So VB squared minus VA squared is minus VA squared by 3 and not plus VA squared by 3. It's one of the most common mistakes, one of the mistakes that we see commonly in almost every wrong answer that has been done. Okay. So what would be VB here? VB will be equal to VA squared minus VA squared by 3. Now, if you're not writing this along with me, I mean, if you don't have this data in a paper along with you, I'm pretty sure you would have already confused yourself a lot, because it won't make sense, and it is not practical to include all the data in one board here, because it will really clog the view. So please make sure, it's a very humble request, that you write down things along with me and then try to interpret this. Okay, right. So VB square is VA square minus VA square by 3. What is VA square minus VA square by 3? It is 2 VA square by 3. Now, taking root on both sides, root of VB square is equal to root of 2 by 3 VA square. What we get is VB is equal to 2 by 3 VA. Okay. Now, what do we do with this 2 by 3 VA? That's where the important point comes in. Why? Because we earlier had an equation which says what? Which says VB minus VA is equal to minus G into TB while going up. What can we plug in? We can plug in the value of VB as root 2 by root 3 VA. Minus VA is equal to minus GTB going upwards. Yes, I think now things are becoming clear to you, right? Why? Because we are close to find out T to reach B, the motion upwards. I would actually suggest that you can pause the solution here, right? Stop watching this. Try to do the rest on your own. Consider the reverse motion. That is from C to A. Apply the same conditions. V is equal to U plus AT. V squared minus U squared is equal to AS. Then try to find out the same time coming downwards on your own. If you don't get the answer, then maybe you can come back and watch the rest. Does that make sense? Please do consider that. Okay? Right. So root of 2 by 3 VA minus VA is, I'm just transposing this minus G. Wait, did I skip a step here? Oh, I did skip a step here. Sorry, my bad. This should be GTB. All what I've done is I have removed this negative here. So that becomes minus root 3. Yeah. So VA minus root 3 by VA is is root 3 VA minus root 2 VA by root 3. And what I have done is I have taken VA as common from these two terms, and therefore this becomes VA times root 3 minus root 2 by root 3 is equal to G times TB is equal to G times TB. And therefore, VA by G into root 3 minus root 2 by root 3 is TB going upwards. What is B? B is the position h by 3. So it is a time to reach the h by 3 height while going upwards, which we will assume it for our ease of calculation as T1. Does that make sense? So far, this conversion is really important. To understand this is the key here. Okay. And how will you understand this? Only if you have the diagram corresponding to the situation. So we have A here, B here. So time to reach P is actually the time to reach the corresponding height, which is the height h by 3. Okay. Now coming to the reverse motion, what happens here? The direction of velocity is reversed. Direction of velocity is reversed, which means velocity is negative. If you're back now, right? If you're back into the solution after trying to do that on your own, and I presume that you got it wrong, which is in fact the reason why you're back here, then first of all, congrats that you have tried it, or tried doing the rest on your own. And please do acknowledge that it is very common to make mistakes. Trust me, when I was doing this problem for the first time, it took me around 7 to 8 attempts to make this part clear. So if you well, of course, I'm not trying to sort of put a benchmark standard of mine here and then comparing yours with that, because my experience in solving, my expertise in solving the question comes from years of experience in teaching, and not at your level of solving the questions. So please don't make a please don't get offended by the statement here. I was just trying to tell you that even after teaching this chapter for many years, I still struggle to do this question with proper amount of detailing. So if you have made this question and made an error by solving this question, it is very normal to be okay to make such a mistake. There is nothing wrong in doing that. To make mistake is human, and making mistakes in these kind of high level questions, it is very obvious thing. Don't demoralize yourself. Don't get your morale down. Don't just keep on telling to yourself that, oh, I made this question wrong even after watching the solution. No, it is very human to make these kind of mistakes, especially when we do questions which are based on directions of motion. It becomes really tricky. Okay, so kudos that you tried to do that on your own. You have made a mistake, no problem. We'll go through the solution one more time. Things will become really clear to you, and then you will not be strong in the question. When will you become strong in the question? When your concepts are really, strengthened. How? When you do this question over and over again. When you do the same question, not by watching the solution, but by looking at your solution that you have written down while watching this, and then speed comes naturally to you. Okay. Right. So acceleration due to gravity is again acting downwards, which is negative. Displacement is, how's displacement? Direction of displacement. Yes, of course it is. From the initial position to the final position, which again is acting downwards, would be negative. So S is negative, V is negative, G as well. Okay. Now to understand this is very important. So just to make sure that you get the things very clear, while the motion of the body is coming downwards, it first reaches a point P where the corresponding displacement, time, and velocity are SP, TB, and VB respectively from SC, TC, and VC. Okay, and eventually it comes to rest. At this position, the displacement is H, and the corresponding position, the displacement is what? It is H by 3. Okay. Now, the first equation, V is equal to U plus AT. What is VB? It is VC plus minus G into TB. Exactly. This is where the mistake comes in, right? Is there something wrong in this equation? You pointed it out correctly. This is wrong. Why? Because velocity is acting downwards. It is minus VB. Initial velocity as well. It is acting downwards. It should be minus VC, which doesn't matter here. Why? Because it is dropped from rest. Okay. So minus VB is minus GT in TB. So minus VB is GT in TB. Therefore, TB is minus VB by minus G. Therefore, you get time as positive, which you might have got as negative. And then you are like, how can time be negative? Time was not negative. It just gives you it points out the error in choosing the reference direction. Okay. So what is TB to reach while coming downwards? Time taken to reach B while coming downwards is VB by G. Now you might be wondering, earlier we had two terms in the equation. Now we have only one VB by G. Then how can we come to the previous answer, which is actually root 3 minus root 2 by root 3 plus root 2? We just have one term here. Now that is where the question becomes really interesting. It is this part where where analyzing the motion becomes interesting. Okay. So when we consider the same motion from v square minus u from C to B by the equation v square minus u square is 2as, where again minus VB, G is minus G. So minus VB square. Okay. Now this is tricky. Why? Because v square is minus VB the whole square. What is u square? It is minus VC the whole square, right? Which is minus VB the whole square is VB square minus VC the whole square is VC square. So VB square minus VC square is equal to 2 into minus G into S is 2h by 3. Oh, I'm sorry. It should be h by 3, right? Is it? No, guys, no. It is 2h by 3. And why is it so? Let's see. Concept. This is where breaking down these concepts becomes really important. So this much height, what you have here is h, right? This complete height here is, let me just write it down as well. So this complete height here is h. And B is at a height h by 3. But from where? B is at a height h by 3 from the ground and not from the maximum height. So when B is at a... Yes, I do understand that this is where most of us have gone wrong, right? Pretty obvious. I think I got myself corrected here in my 4th or 5th attempt. And even then I had to make mistakes in the coming calculations. So that's more than okay to be, okay? Just don't be disappointed by that. It's pretty common to do so. Okay, now, so B is at a height h by 3 from the ground, which means it will be at a height of this much, which is actually h minus h by 3, which is 2h by 3. So VB square is VC square minus VC square, which is 0, equal to 2 into minus 2gh by 3. So VB square is 2 into minus g 2h by 3. Wait. Okay. Now comes the, look at this. I made a mistake again. So displacement, I made another mistake here. Can you point out what that is? Take a minute. I've made another mistake here in setting up this equation. Why? Because if I write this, I will get VB square is minus 4gh by 3, and you cannot find the square of a negative number unless we're talking about complex numbers and JEE maths. Velocity can't be complex. What is that? I'm pretty sure some of us might have understood the correct point here, which is, since displacement is acting downwards, displacement should also be negative. So this should be minus 2h by 3. And therefore, negative times negative is positive, which gives us VB square is positive 4gh by 3, or otherwise VB is equal to root of 4g by 3. What is h? We already have found it as v square by 2g. And therefore VB square is root of 4g, root of 4, which is 2, g by, sorry, g by g is 1, 4 by 2 is 1. So, oh, sorry, 4 by 2 is 2. Okay, I'm not taking the root here. So VB square, now taking root on both sides, what we get is root of VB square is VB, root of 2 by 3. Wait, what am I doing here? Oh, that was the same step that I've repeated again. Sorry, my bad. Now taking root of both sides, what we get is root of 2 by root of 3 into VA. So velocity at B coming downwards is root 2 by root 3 VA. Are we done? No, because the point is not to find out the velocity, it is rather to find out the time at the corresponding velocity, right? That is where we have this equation. VB by G is equal to TB. What is VB? We just found out to be root of 2 by root of 3 VA, but where is, are we missing something here? Something that we really need to understand here is this is where most of us make a very common mistake. VA square is positive. Yes. But VA is negative. Why? Because velocity is acting downwards. Therefore, well, see, from here, you can actually directly go for this positive value. I do understand that. But if you haven't considered this negative here, then VB should be taken as negative here. Listen to this very carefully, okay? Give you maximum focus. If I wouldn't have considered this negative by negative as positive here, I would have ended up in a different zone, right? And then I'll feel that time is, if I made a mistake, then I will get time as negative. But why am I getting that mistake? Because I'm substituting VB as positive direction here, which is not the case. Why? Because velocity is acting downwards and therefore it should be negative. And then we get negative by negative as positive. Okay, right. So, yes, time to reach B while coming downwards is root of 2 by root of 3 VA by G. Now, we didn't get anything of the form root 3 minus root 2 by root 3 plus root 2 again. We are stuck. Are we? Well, if not, we do it properly. So, very important to understand that time to reach B while coming downwards, or maybe time to reach B when dropped from C, is root 2 VA by root 3G. Let us visualize this. Okay, let us visualize this. Time to reach B while coming downwards is equal to time to reach B from C is equal to time to reach B from C. Time to reach B from C. But what is TA, time of ascent? Time of ascent is time taken to reach C from A. So this is time to reach C, and then, so this much portion here is time to reach ascent, and then this much portion here is time to reach C from B, time to reach B from C. And at this instant of time, we are at this position, we have two instances of time. Okay. Well, actually, I'm also exhausted. Maybe that's why I'm not able to explain this well. Please go out, watch it one more time and talk to yourself. And I'm pretty sure that if you have written this down along with me, and if you talk that to yourself, things will become really clear to you. Okay. Now, if I were to write this in equation, time to reach h by 3 height, which is this, while coming downwards, is actually equal to time to reach the apex position or time of ascent plus time to reach the same position at P from C. time to reach B from C. What is time to reach the apex position? It is VA by G. What is TC by B? It is root of 2 VA by root of 3 G. Right? Now I can say that time to reach H by 3 downwards, if I take VA common from here, is 1 by G plus root 2 by root 3 G. Sorry, I missed that. Now, multiplying root 3 here in the numerator and in the denominator, what I get is VA into root 3 plus root 2 by root 3G is time to reach H by 3 while coming downwards. So we have two values. Which are they? Time to reach H by 3 upwards is VA into root 3 minus root 2 by root 3G. Time to reach H by 3 downwards is VA into root of root 3 plus root 2 by root 3G. Okay. Now, taking the ratios, what we get is root 3 minus root 2 by root 3 plus root 2. Wait, what is an arrow mistake here? Yeah, this is not upwards, this is downwards. Yes, I do understand, guys. It's a very lengthy explanation because I just wanted to make sure that you don't make any mistake in any of the formulas, in any of the sign conventions that we use. Okay, are we done? Yes. So far, so good with the solution. Now we need to spend some more time to understand the symmetric nature of this. Please don't, it's a very humble request, please don't skip the solution without writing down and without following what has been discussed with respect to symmetry in velocity, in time, and in displacement. So very, very important concepts. In fact, they are very crucial. That I do expect a very potential. I would say that this is a very potential area for a upcoming question in the JEE mains. Okay. So let's first discuss about the displacement symmetry.